So here we need to find out the minimum distance from the eye at which a coin having a diameter of 2.2 centimeter must be held such that it's going to completely hide the moon. It's also given that the angular diameter of the moon is 30 arc minutes. Let's try to understand the problem first. So here we have the moon and we have an observer at E. Now let's consider the E to be the center of a circle such that the moon is subtending an angle at the center or at the eye of the observer, and this is given as 30 arc minutes. Now let's try to convert the angle 30 arc minutes to degree first. So here we know that if we have 60 minutes, so that corresponds to 1 degree. So 1 minute is going to correspond to 1 over 60 degrees, which means that 30 minutes is going to correspond to 30 over 60 degrees, or simply 1/2 degrees. So 30 minutes corresponds to half a degree. Now for our calculation purpose, we'll also have to convert the degree measurement to radians. So here we're going to use the fact that 180 degree, that corresponds to pi radians, which means 1 degree will correspond to pi over 180 radians, such that half a degree will correspond to pi over half times 180. So this is going to be in radians. So that means we have half degree is pi over 360, and this is going to be in radian. So we have converted the angular diameter of the moon from minutes to the radian, so that's pi over 360. Now the problem says that if we place a coin such a way that it's, let's say it's at a distance of r from the observer's eye and is going to completely hide the moon. So that means this particular coin which has a diameter, its diameter is given as 2.2 centimeter. So this particular coin must also have an angular diameter of 30 arc minutes, or pi over 360 radians. Then we can use the formula theta equals to arc length divided by, this is going to be the ratio of the arc length to that of the radius. Now in our case, theta we have obtained, that's pi over 360. So here arc length is nothing but we can consider to be approximately equals to the diameter. So here we can consider this to be approximately the diameter of the coin, and the diameter of the coin that's given as 2.2 centimeters. So we will substitute this value here, and that's going to give us 2.2 divided by r. So solving for r, we have 2.2 multiplied to 360 divided by pi. So this gives us a value equals to, so our value is going to come in centimeters. So we have 252.101 centimeter. So the closest we can see here that it corresponds to option number B. So that means the coin must be placed 252 centimeter from in front of the eye, such as it completely covers the moon.